Hey everybody, this is my walkthrough for the 2019 free response problem about circuits. And really it's not just about circuits, it's also a little bit about gravitational potential energy. It's always fun to see areas of physics mixed together because we chunk it throughout the year and go through mechanics with kinematics and then forces and then energy, and then we move on to waves and subharmonic motion, and now we're in circuits. But it's really all physics, and it all relates to each other, and that's what this one's getting to. The idea of electrical power can just be related to mechanical power. So, determine an expression for that power in terms of m, h, t, and fundamental constants. Yeah, seeing that resistor there, we might think P equals I delta V, or I squared R, or delta V squared over R. But this one says, no, power. Think about the rate of change of energy. And in this case, we're getting some gravitational potential energy out of this, turning electrical potential energy from the battery into gravitational potential energy. And however much we're getting is the gravitational potential energy divided by the time. So mg, and that's capital H, divided by delta t. That would be power. How much energy you're getting per second, whether that's you running up the stairs or whether it's a motor lifting a block. That is a good way to talk about the rate of change of gravitational potential energy. Then the problem says, all right, here's this other resistor, R2. This is R1. And this other resistor has more resistance than R1 does, and you want to decrease delta T. So the key is that I want to increase power. To increase power, you need to increase current. In the motor. That's a big idea because the motor is the thing doing the work. And electrical power is P equals I delta V, or delta V squared over R, or I squared R. And I want this motor to be doing more, and I want to have more current be delivered to it. That's more charges, more electrical potential energy, more. This is a good use of equations in your paragraph length response, that you can say, look, that as the current goes up, the power goes up. There are great sample responses that are posted in the AP solution guide. Take a look at those. What I'm highlighting here are kind of just the thoughts behind those questions that people emailed me about and said, Mr. Templin, can you tell me more about why adding resistor R2 in parallel will increase the resistance? And the video I posted about the 2016 one, I said, you know what, let's talk about these 10 ohm resistors again. 10 ohms of resistance is just 10 ohms of resistance. That's all it is. But two 10 ohm resistors in series? Well, that's equivalent to 20 ohms of resistance. And I wouldn't put this in the paragraph length response. This is what I would put is the idea that connecting R1 and R2 in parallel means the combination has less resistance than just R1 by itself. Let's say it was a 10 ohm resistor and a 20 ohm resistor in parallel. Well, the equivalent resistance to them, I can calculate. 1 over 10 plus 1 over 20, 1 over that is 6.666666666, less than the total resistance of just the 10 ohm resistor. That's what parallel does. You can add resistors together to make there be less resistance than there was before. it makes it easier for the charges to flow because they have different paths to go. That's going to increase less resistance in the circuit. Will increase the current in the circuit. And that's Ohm's law again, and Kirchhoff's loop rule. It's still the same battery, still delivering the same potential difference to the entire circuit. But we overall have less resistance now, so that's going to mean more current, more and more and more. Because there's different resistors that need to have current going through them and different pathways to go. So that's kind of the most common question people are saying. How could you connect another resistor to actually decrease resistance? And that's what happens in parallel. So there's great questions on that about light bulbs on your Mastering Physics that follow up with that idea. If you have any more questions about this one, feel free to email me and we'll talk some more. Thanks.